physics-13.1 if recognize and use the equation of x-t and the equation of v-x in simple harmonic motion. Question 1. Recall the two equations. Question 2. How to understand the equation relating v to t. Question 3. How to deduce the equation relating v to x. Question 4. What we can do using the equation relating v to x. So the v-t equation is v equals to v sub 0 cosine omega t. And the v-x equation is v equals to positive or negative omega times the square root of everything in the parentheses, which is x sub 0 squared minus x squared. Well, omega, same with this omega, is the angular frequency. X is the displacement of the oscillator, which is defined as the distance from the equilibrium position. And x sub 0 is the greatest x, so it's also the amplitude. And here in this equation, v sub 0 is the greatest speed of the oscillator, and it's the speed when the oscillator passes through the equilibrium position. And this moment is when we take the time t equals 0, so it's the start point of time. And we use the whole equation, which is a cosine function, to represent the velocity since then. And that's for the question 2. Now let's move on to the question 3. To derive the v-x equation, which is this equation. Generally speaking, the routine here to get this equation is to combine the x-t equation and v-t equation to cancel t. And if we get into more details, it's not this. So we have x-t equation as x equals to x sub 0 times sine omega t. Rewrite it as this. Then square it to get this equation, labeled equation 1. And we also have v-t equation right over here. And do the same agenda. Rearrange it, then square it to get this equation, labeled equation 2. And then we add the two equations together. The left side will be this. And the right side, sine squared plus cosine squared, is just equal to 1. So t in these equations cancels out, and that's what we want. Let's continue with this equation here. We want v on the left side, so we get v squared equals to this bunch of things. Then we take the root square. We get v equal to this expression. Compared to the final equation we want, you'll find they're so similar. The only difference is this. In this orange rectangle I drew here in dotted line. So what we should do next is to prove they are equal. V sub 0 over x sub 0. And if you want the omega out of a sine or cosine function, the only way is to take the derivative of the function. So we take the derivative of the function of x with respect to t. We get the derivative of x equals to x sub 0 times omega cosine omega t. And the derivative of x with respect to t is just the velocity v. So what we get is a v-t equation. Compare it to the previous v-t equation. or just set t equal to 0 in the equation, we'll get v sub 0 equals to omega x sub 0. Then plug it into this equation. We'll get this equation, the equation we are asked to derive. So that's for question 3. Now let's move on to the next question. What we can do using the equation we have just derived, the v-x equation. Apparently, we can use this equation to deduce the speed of an oscillator at any point in an oscillation, given any x. For example, if the oscillator is at the equilibrium position where x equals to 0, then substitute 0 for x in the equation. We'll get the maximum speed v sub 0 equals to omega times x sub 0